Hey everybody! In last week's video, we started dealing with larger datasets by using data frames and lists in our programs. Throughout this process, we looked at our original raw data from the US Census Bureau and cleaned it to look for specific data that we needed for our program. Instead of focusing only on the mathematical, life science, and physical science occupations, in today's project, we'll be working with all of the occupations. I've already cleaned and processed the data we'll be using in today's project based on the techniques we learned about last week. The dataset is available for download on askthecat.org and linked in the description of this video. Using such larger data, we'll be able to employ tools from the Tidyverse toolkit. But before we explore what those tools are, let's first understand what Tidyverse is. The Tidyverse is a collection of open-source R packages used for data manipulation, exploration, and visualization. A package in R is a collection of functions, data, and compiled code that are grouped by their similar purposes or goals. There are 8 core Tidyverse packages that are organized here based on their use in data visualization and exploration, data wrangling and transformation, data import and management, and functional programming. We'll be focusing on these first 2 categories for our video series, with a specific emphasis on ggplot and dplyr. All of these packages are loaded automatically at once with the install.package tidyverse command. In addition to these packages, Tidyverse also has some specialized packages that are not loaded automatically but need their own call, such as DBI for relational databases or rvest for web scraping. We won't have to deal with these topics in this series, so we do not have to worry about loading those packages into RStudio. In today's video, we'll also be using functions defined in the dplyr package, and so I call the library function on the package. The library is a specific location where packages are stored in. Since we want the dplyr package specifically from the Tidyverse, we use library to ensure the package is stored into our local library for later use. Now we're going to use the data that I previously cleaned and upload it to our Files tab in RStudio. Remembering last week's review of data frames, we'll use the following line of code to load our CSV data into a local data frame that we can use. The first function that we're going to use from dplyr is filter. Filter, similar to our subset function from last week, extracts a particular element from our data frame based on a specific condition. Filter tends to be more targeted and nuanced than subset, since we can specify multiple conditions within our filter function, as shown through the following example. A quick aside, in order to use the filter function, we use a specific syntactical symbol called a pipe, the percent sign followed by a greater than sign and another percent. The pipe is there to allow us to take the output of one function and then pass it through a different function as another argument. This allows us to connect a sequence of analysis steps, as we will see when we combine different dplyr functions later in the video. In this first line of code, we are piping our data frame and calling the filter function to filter through all of the observations listed in our data and select only those whose total value is greater than 1,000,000. While we have significantly reduced the amount of jobs listed, we still have a lot of variables shown after calling this filter function. Let's say that we wanted to focus only on computer occupations and see how many of those jobs have more than 1,000,000 employees. Now we add another condition to our filter function, checking first if the observations are in the computer occupation category, and then seeing if more than 1,000,000 employees are in that job. Now we have an even smaller snapshot of our larger data frame. We can keep playing around with these conditions, seeing how many of these computer occupations have more than 50,000 women employed, and even how many of these STEM jobs have more women than men. Note that after filtering through these observations, they are not affecting the original dataset. We can always assign these snapshots of the larger data frame into a new data frame using the usual syntax necessary to create new variables. Or we can set it back to itself so that those changes are now shown in the original dataset. For the sake of this project, I'm not going to run the latter so that we can always have the original clean data as a reference. Another function you can use is arrange, which allows you to sort observations in ascending or descending order based on a specific variable. For example, we just created a data frame that only contains jobs in the computer occupations category. Let's say we want to arrange that information based on the total amount of people employed in those jobs. All we have to do is pipe the function arrange and specify that we want to arrange the data based on the variable total. Note that arranging automatically orders the data in an ascending manner. To arrange the data in a descending order, we have to specify that in the arrange parameters using DESC like so. Mutate is a function that will allow us to change all the variables in a given column, or create an entirely new column for those changed variables. For example, if I wanted to divide all the total values by 1,000, I can do it in one of 2 ways. First, I can create a separate column called total divided to contain those changed values and leave the original column unaffected. Or I can set the original column back to this change variable type in the second option. The summarize function can help us to represent an entire data frame according to just one operation done on a variable, and save the results into a separate column in our data frame. This is useful for consolidating data among different observations and understanding larger trends with the presented information. For example, the following operation allows us to see how many total employees have computer occupation jobs, and if we cross-verify it with the raw data from the U.S. Census Bureau, we see that we get the exact same value that they had calculated. Besides the sum function, we can also do the same operation using max, min, mean, and median. Finally, the group by function allows us to take our original data frame and group it by a specific variable, allowing us to perform the following operations on each of those groups. Taking our last example a step further, we can pipe the summarize function with the group by function and find the total number of employees in each job category, saving each of these values into a separate column in our now grouped data frame. And if we cross-verify it with the raw data from the U.S. Census Bureau, we see that we get the exact same value that they had calculated. I hope this video helped you to learn more about the dplyr package in the Tidyverse collection, and how we can use it to manipulate larger data frames in our R programs. Next week, for our final video in the R Winter series, we'll be exploring the use of ggplot in creating easily accessible and readable visualizations for our data.